To get started today, remember the topic we are in is 7.2.1 proportionality. And then you can add your name and the date to today's notes. In today's notes are lesson number 2, I can determine proportionality from tables. So we are going to be specifically looking at tables to figure out, is it proportional or not? So remember, to figure out that proportionality we talked about in the last lesson, and we're going to look at different things in this lesson to establish proportionality. And the first thing that we need to know is this vocabulary word. And this is going to be a very, very important word that you see throughout this entire unit and in the future. It is the constant of proportionality. And all that is the ratio between two quantities. That's it. And I always think of this, it's really just a fancy way of saying unit rate. So if you can remember the constant of proportionality is simply the unit rate, you'll be just fine. Now, in order to find that constant of proportionality, we have an equation that we use. So the constant of proportionality, somebody decided at some point in time they're going to represent that with the letter K. And to find that, we always take the y value divided by the x value. Now, make note, it's y divided by x. Y divided by x. Write that 1,000 times so that you don't forget y is on top when we're trying to find the constant of proportionality. Do not flip that around. So knowing how we find that constant of proportionality, we can establish if a table is proportional. So when we look at a table, the first column, or whatever is on top, whether it's going long ways or up and down, top x always is going to come first. So it's either x over y or x then y. And what we need to do is we have to take each of these pieces of our table, so each row in our table, and we have to figure out when I divide them, when I find that rate, is it the same in each row? So y is 26 divided by x. 26 divided by 2 is 13. If you need to use a calculator, you can. Next row, 39 is my y, 3 is my x, it equals 13. Next row, 78 divided by 6 equals 13. Next row, 130 divided by 10 equals 13. And last, 146 divided by 12 equals 13. Notice when I found that ratio, each time it's simplified to the same thing. So when I'm determining proportionality, I can say, yes, the table is proportional because, so I've answered, is the table proportional? Now I have to state why or why not. It is proportional because each row has the same constant of proportionality. Okay, so notice a few things here. For each problem like this, you have to have that entire sentence written out. Because the first question is my table proportional? I answered, yes, it is. The second part of that question says, why? Why or why not? I said why. Each row has the same. And then we want to make sure we're using the right vocabulary. My vocabulary in this case was that constant of proportionality. So this sentence here thoroughly answers the question. We'll be looking for that on your assignments and assessments in this unit. When tables are proportional, we can also write an equation to describe what's happening. And the equation is the following. It's y equals k times x. But we know k is the constant of proportionality. Constant of proportionality. And that's always going to be some number. So k is going to turn into a number, while y and x will stay y and x. So looking at this next example, is this table proportional? Why or why not? And if it is, we can write an equation. So we always are taking, remember, y divided by x to figure out proportionality. Here is my y, here is the x. So when I look at each row of this table, I need to see, will it simplify to the same thing? So 2 divided by 6 equals 0.3 repeating. Remember, you can use a calculator. 3 divided by 9, 0.3 repeating. 8 divided by 24, 0.3 repeating. 1 divided by 3, 0.3 repeating. So, in each case, I ended up with the same thing. And also, it's important to note that 0.3 repeating is really just 1/3. So is it proportional? Why or why not? And write an equation if it is. So is it proportional? Yes. Why or why not? Because each row has the same constant of proportionality. Notice I'm using that vocabulary word. And then it says write an equation. So remember up above we have that generic equation form. Y equals kx. The only thing that's going to change is the k will become a number. The number is whatever that constant of proportionality is. I figured out it's 1/3. So my equation is y equals 1/3 x. We don't like to use repeating decimals in equations, which is why I chose to use the fraction. And then lastly, we have one more example, and it's asking, is the table proportional? Remember, to figure that out, we always are going to do y divided by x. So in a table that goes up and down, we have x first, then y. And when I look at each row, I'm going to have to divide. Now in this table, the first row has a 0. Anytime there's a 0, I don't like to use that row because it sometimes will skew my data. Because we would have to do 4 divided by a 0 and can't divide by 0, so that's just not a nice number to work with. So we're only going to focus on these bottom 3 rows, and it's still going to give us accurate data, so it's okay. So the first is 10 divided by 2, which is 5. 16 divided by 4, which is 4. I can stop right here. I don't have to do that last row because already I see these are not the same number. And so when it asks, is the table proportional? No, it is not proportional. And then I have to make sure I say why. It's not proportional because each row had a different constant of proportionality. Please make sure you're using that vocabulary word in your explanations. And then because it's not proportional, when it comes to the equation, we cannot write an equation for this table yet. Eventually we'll learn that, but not in 7th grade. So we don't have to write the equation, we just have to explain why it is not proportional.